Right. I'm going to talk about notation. I had two talks I did specifically about how to notate pitches on my guitar. This is going to be more general, so I'm going to talk about what the standard European pitch notation actually means. So to start off, what is standard European pitch notation? It's what's used with staff notation. An example of staff notation is here. It's also what's used with Genpu, and Genpu is there. So this is often called a Western notation. I think that's a bit vague. I never know what people mean when they say Western. This is a form of notating musical pitch that originated in Europe and is now relevant globally. I'm going to focus mostly on 16th century Europe for the origins of this notation. To start with, though, let's go through the history of it. It originated in the 11th century. It was devised by Guido of Arezzo, who was an Italian monk. He wanted a way of writing down tunes to help his singers remember them. He invented the 7-note staff. There are 7 notes to the octave. We could play them like this. He was, there are 2 variable pitches. There was a theory of hexachords. Now, I need to pay attention now because I keep getting this wrong. Let's see how I do it now. The first hexachord on C, it had standard syllables, and I'm going to try and sing it. So here we go. Ut, re, mi, fa, sol, la. And so there are only 6 notes in the hexachord. That's why it's a hexachord. It doesn't actually cover the entire gamut with the modes that were used at the time, which had 7 steps to the octave. There were 2 other hexachords that were part of this standard system, known as musica recta. And pay attention, let's get these right. Ut, re, mi, fa, sol, la. That was right, was it? Ut, re, mi, fa, sol, la. So there you go. So there's a difference in that pitch. And that was written by choosing which hexachord was active at any given time. And so composers were aware of this. The singers were trained to know which hexachord they were using for their singing. And this is not the way we do it now. Now we say that the note B has 2 different pitches, B, B flat. And that idea took hundreds of years to develop. Steps along the way in the 13th century was it Johannes de Garlandia. He seems to have been the first person to actually describe an accidental as lowering a pitch by half of a tone. So a whole tone divides into 2 semitones. That idea comes from the 13th century, but it was not the standard way that theorists were thinking about this. They were using 2 symbols to specify where the pitches fa and mi lay on the hexachord. So if you have B, it would be mi, re, mi, fa, sol, la. If you had B flat, it would be fa. So ut, re, mi, fa, sol, la. So that's that. These symbols evolved into the sharp and the flat. By 1400, they were able to write B flat, D sharp, D flat, A flat, and G flat by using different hexachords. Any hexachords that lay outside the original 3 were called musica ficta, and so this became a term for accidentals outside the basic 8 notes. So we get to the 16th century. In the 16th century, theory was in a phase of revolution, because in the 15th century, the basic consonances had changed. In medieval Europe, the consonants were the fifth, fourth, and the octave. In the 16th century, thirds became like triadic chords, and so I'm going to have to quickly change the tuning. We move over here. So the introduction of the major and minor thirds as consonances meant that all music had to be rewritten, and also singers had to learn to sing new pitches, because if you sing them in Pythagorean intonation, they'll be slightly out of tune. So there we go. That should be compared to... No, of course that's out of tune because I got the wrong tuning up there. Hang on. So that's a bit better. It's a Pythagorean triad. Ooh, let's try a bit higher. Oh yeah, no, it's all in the tune again, isn't it? That's it. So we've discovered there that how you tune is important, particularly if you have it set wrong. So 16th century, we'll go to Willaert. Willaert was a Dutch composer who was working at St. Mark's in Venice. Venice is a cosmopolitan city. There were most certainly Arab traders in Venice in the 16th century. So we're talking about European music here. Some of this was open to influences from outside. So there were 3 different tuning systems that Willaert was working with. One of them, let's switch it to get it right, Pythagorean intonation. The second was just intonation, 5-limit just intonation. So Pythagorean intonation, let's step back. This is a tuning with a long history in the Mediterranean and beyond. It's based on the octave and the perfect fifth being exactly in tune according to the harmonic series, which is a thing we get told off for being too mathematical about. But this is a readily apparent sound to the ear. It isn't a universal of human music. There are lots of cultures that don't use it, but it gets used quite a bit. And it is named after Pythagoras, who was a Greek or Phoenician philosopher from a long, long time ago that we know almost nothing about. But in practice, it was a tuning originating in the Eastern Mediterranean. A second tuning, just intonation, 5-limit just intonation using pure thirds, is generally traced back to 1st century Egypt and Ptolemy, Claudius Ptolemaeus, a theorist with a Greco-Roman name who we don't know he was Greek or Roman. He was probably actually Egyptian. So we have 2 tunings who both have an origin in the Eastern Mediterranean and so are certainly not Western. The third tuning is the one that's the current global standard, basically Chinese, but also does show up at various times in various guises in the Mediterranean, originally by Aristoxenus. And this is 12 nodes equal temperament. And that theorists in the 16th century generally don't like that as a standard tuning. The ones who do played the lute. Lute is a fretted instrument. It is known across the Mediterranean. It's obviously Arabic in origin because it has an Arabic name, al-ud. And so the 12-note system, it is known, it isn't always favoured. It is currently not favoured in the southern Mediterranean, but there were lutes used in the southern Mediterranean in earlier centuries that actually got pretty close to equal temperament. This is possibly how it spread into Europe. But we don't know. At least it was an idea that was there in the 16th century. Willett wrote a tune, a four-part motet called Quid non ebrietas designat, which means, did I write down what it means? What cannot be accomplished through drinking. And so this, I think this is interesting because some of us work with what we call comma pumps. I did this in my tune called Golden Age, wasn't it? And a comma pump can have the effect of seasickness. It makes you feel a bit queasy because like the basis is shifting. You find yourself in a different place to where you started. This feels like motion and it makes you feel queasy. It's interesting that Willett did this and he related it to drinking. It's a thing from Horace. So what he did is by moving by Pythagorean intervals, which and then moving by a third, he effectively made E double flat and D the same. Now, he didn't exactly do that because he didn't write a picture's E double flat, because at that particular point in history, they didn't have double flats and they weren't writing pitches. He was using the hexachord system with the ancestors of flats and naturals to point to this particular modulation, and as it's written, E was the same as D. So this is an equivalence, it's an enharmonic equivalence, and we will know it from 12-note equal temperament. But Willett was probably not working in 12-note equal temperament. He began the motet in Pythagorean intonation. The final move was a 5-limit third, and that got him a schisma, a 2-cent interval, a tiny interval away from where he started. So, interesting thing about the schisma, this was known in theory in 11th or 12th century, I forget. At least, no, I forget when it was, but it was by Safiuddin al-Amawi, who was a Persian theorist working in Baghdad and writing in Arabic. So, did Willett know about this? I think in Venice, it's quite plausible he did. But of course, we'll never know because Willett was working in an oral tradition. He was an important teacher. He was training his singers, but he didn't leave us a treatise. He was working with written music. So it's possible that Arabs in Venice were sharing these ideas. We don't know exactly what relevance schismatic temperament actually had to any Arabic music. And it's possible it was just an independent invention. It does come up a few times in Europe in the 15th century by ways I'm not really sure about. And it's possible that it was discovered by experiment. And this is easy to do. If we take a major triad, play it in Pythagorean intonation, and that is correct tuning, isn't it? If we try transposing it to different positions, oh, there we are. So well, where are we exactly? If you play a major triad correctly in Pythagorean intonation, it's out of tune slightly, like that. It's an active chord, I think we say. If you play it with the wrong accidentals, so what am I starting with? I think I'm going for B, D sharp, F sharp. That definitely. This is a standard 12-tone keyboard. It doesn't have a D sharp key. What it has is E flat. When you play B to E flat, this is much better in tune than C to E. So that's the principles of schismatic temperament. It can be defined mathematically. It was defined on a 17-note scale by Safiuddin al-Umawi. Maybe it was the 13th century, but it was definitely in advance of this. And it is one of the basic regular temperaments. It's come up in our theories and so on. It's mathematically justified. You don't need mathematics to find it. And so all these three temperaments were relevant to Ouellet with the motet he wrote, and this is known by 1524. We don't know when he wrote it, but we know it was discussed by theorists in 1524. And so this is the situation of pitch in the 16th century. They knew that in the past singers were using Pythagorean intonation, that the music of the past in Europe, Pythagorean intonation was the ideal tuning. They knew that the new music that they were writing, this revolutionary new music, a few decades old, required a different tuning that had pure thirds. And they were trying to work out how to sing it accurately, how to notate it. And so now we move on to Zarlino, who was a student of Ouellet, also I think in Venice. And Zarlino came up with this picture, which is extremely interesting. Zarlino is Italian. It would probably be Zarlino, but I'll call him Zarlino for the purposes of this. What we have here is a picture of a keyboard with 19 notes. If you count them, there are 19 notes to the octave. The names at the bottom, I'll try and follow this, it's all backwards to me. These are the musica recta names. So that's A, B, C, D. But where we have a B, it's written as a hard B, which you will probably recognize as a natural sign. So that's the first thing. So as Zarlino was writing this, he was still using the recta system that was developed by Guido of Arezzo back in the 11th century. Because at this time, the notation actually required to describe this wasn't there. But the other interesting thing about this is a demonstration of mean tone temperament. Now, mean tone is an original European tuning. It is, I think, a lot of us would say, the most important tuning of European music. It doesn't show up anywhere else. Possibly it was used in China several centuries BC. There's one famous set of bells that appears to be following the rules of mean tone temperament. As we could have a digression on universality here. Some people suggest that certain facets of music are universal, like the octave, the perfect fifth. This is not true, but they are not completely arbitrary. You can hear the octave, you can hear the fifth in sound, they're present in overtones. And so, although most cultures don't give them any importance, cultures can independently come across them. So it appears that mean tone temperament was known at a certain point of Chinese history, but there's nothing written about it. All we have are these bells. So in Zarlino's time, nobody knew that this was Chinese. 12-note equal temperament also originates in China in the Han Dynasty, but I don't think that was generally known in the 16th century. So no, they didn't know that they were working with Chinese ideas. 12-tone equal temperament is an obvious system. It's not at all arbitrary. It comes up all different places, probably independently. It is probably independent between China and the Mediterranean. Right, so that's that. So the point of mean tone temperament is that every written note has a unique pitch in mean tone temperament. So this diagram, as we've seen, predates our modern understanding of the notation system. Zarlino didn't have a notation to call all of these pitches unique notes. But we can say that the black notes here are, so this one is B flat, C sharp, E flat, F sharp, G sharp, and then on to B flat again. Each black note relates to a white note by one step. The sharp or flat operator acts by moving it one step on this keyboard. Zarlino knows the mathematics. He has all these positioned in the correct place. Now, once you have a notation system with sharps and flats that can be applied arbitrarily to any pitch, then you have a description of mean tone temperament. This came about at some point in the 16th century. This is why I say that the 16th century is the true origin of the European notation system. It began much earlier in the Middle Ages, but the pitches weren't given their modern meanings. We didn't have the system of sharps and flats, and we were assuming a different tuning. So the point of mean tone temperament, I'm just going to switch this. There you go. You didn't notice that, did you? Point of mean tone temperament is the fifths that are all narrow. Fifths are all narrowed. So these are flat by a few cents, which is a noticeable difference from the true ratio that we heard with Pythagorean intonation. The reason for doing that is that each note exists once on the keyboard. We can get through 4/5 and end up at a major third. And that major third is almost perfectly in tune. This key, actually, why don't you have a look at the keyboard? There we go. I think that's there we go. So it's on the blue notes here. So hopefully you recognize that as being in tune. Some people will say no. I know from the previous videos, some people find mean tone to be out of tune. It probably depends on how much ear training you've done with standard 12-tone intonation. But there we go. So mean tone temperaments establish themselves as keyboard tunings in the 16th century. Some singers were working with just intonation. Lutenists were generally working with equal temperament. There was a mixture of things there. But the notation was definitely being driven by mean tone. Quarter common mean tone is an optimal tuning of that. Zarlino eventually came round to it. This is very close to the division of 13 steps, which is on this keyboard. And let's just try that. So on. So a whole tone is divided into 5 steps, a semitone into 3 steps. So the crib is this magic diagram here. If you ignore these enharmonic notes, which were read you get the 12-note scale. If you consider all the pitches, you get the 19-note scale. If you count the number of steps in a 12-step scale, add it to the number of steps in the 19-step scale, you get the number of steps in the 31-note scale. And I'm not sure who actually discovered that, but it's the logic behind it. Once you have your 12-note keyboard and your 19-note keyboard, you know all of mean tone. By using a system of 7 nominals with sharps and flats, you can uniquely address mean tone pitches. What you can't do is notate 5-limit just intonation. In 5-limit just intonation, there are also 3 commas. And so these commas got lost from the notation in the 16th century. And we have the modern system of notation that can address mean tone, but not just intonation. In mean tone temperament, in an optimal mean tone temperament, like 31 equal or quarter comma mean tone, C sharp is lower than D flat. Look at this. Well, we established the tuning. So this is the semitone. It goes that direction. Tone goes that direction. If we want to find C sharp, we bring that semitone. It's there anyway. It's there. So a sharp moves one direction this way. C sharp, D flat. C sharp, D flat, D. And so if you want a general rule for European notation, you can say C sharp is less than D flat. The relative tunings of B sharp and C flat are not clear. On the 19-note keyboard, they are the same. Oof, there we go. It's this key here. Most people weren't tuning to 19-tone. It was used by Guillaume Coatley. It was theorized by Salinas. But let's see, it was simply one of the tunings used in the 16th century. Now, over time, there were a number of keyboards that were made for this. This article I've got the woodblock from. It's by Christopher Stembridge. It's about keyboards with more than 19 or more pitches to the octave. And so Zarlino did have one of these made. The keys were split horizontally like this because that was easier to play than having them vertically. The diagram here is useful for understanding the scale. It is not a practical blueprint for building an instrument. There were many instruments with more than 19 notes in the 16th and 17th centuries, but they were elite instruments because they have more pitches than you need. They cost more money. You have to be rich to afford them. And so, poverty won the day. Because 12 notes are all you need to express the major minor key system as developed in the 18th century. The keyboards with more keys fell out of use. And we now have a system where, because composers want to transpose, to put their keys on different positions, and they only have 12 pitches, we've moved towards a system of equal temperament. And this is a good system, but it is lacking certain things. And many people assume wrongly that the notation system is founded on that. And I hope I've shown that to be wrong. So we come to modern times. So because the standard is 12 notes, those of us who want to use different tunings are put in a category called microtonal. And anything that doesn't follow the widespread standard has a special name. It's different. And let's see if I can switch to my guitar. We go to this. So there we go. I hope I wired this up properly. Here we go. So this is using a system. It's called Magic Temperaments. I think I'll turn it up a bit. So we have to go up here. This is a 19-note fretboard, but it also has commas. You can see the commas. In this place, the commas explicit. There are 2 pitches. In other places, the commas are slightly wider interval. So this is a gap where an extra fret should be. So to get from mean tone to just intonation, you need to add 3 commas. This fretboard has no connection with mean tone. You can't count up to 12 here until we get to here is the octave, but it follows the 19-step scale plus 3 commas. So because of this, it's possible to take a pitch from standard notation and use it to describe a fret on the guitar. So in microtonality, there are 2 ways of adapting standard pitch notation to work with microtonal scales. The first is to treat the 12-note scale as the standard, to treat each pitch as having a range of pitches, and to notate to the nearest one, and also notate any significant deviation. The other is what I generally follow, is to actually interpret standard notation as not being tied to 12-note intonation, to treat it as either a mean tone or possibly a Pythagorean notation, and then to add any extra symbols you need to get to the scales you're using. So this guitar does require commas to describe it properly, and I won't go into the details of that because it's just one thing. So the reason I say that, say if I play it here, so this is the A, so that's a C sharp, isn't it? This is an interval of a major third. This is pretty close to a pure major third. It's 6 cents out. It's more than twice as close as equal temperament. Every interval up to, I think, 11 limit just intonation is nearer in a good magic temperament than it is in 12-tone temperament. So this is a major third. It is described as A to C. This isn't taking the notation and changing it. This is the way the notation applies to a system that approximates 5-limit just intonation. The notation was used in the 16th century to apply to 5-limit just intonation, with the caveat that there are sometimes 2 different pitches that have the same name. So if this is C, this is C sharp, because that's a minor third, and a minor third is notated in a particular way, and it's associated with a ratio of 6:5, which this is pretty close to. So this is how I assign standard pitches to this guitar. Well, there we go. Let's just play. What I was going to say is I do have another system that I think is over here. Here we go. So this is tripod notation. So tripod notation was devised specifically for magic temperament. It has 9 steps to the octave and has special accidentals that point to these. I've now moved on from that. I found when I was working that, it was possible to write the music using that notation, but it was difficult to think about. And certainly when I moved on to the guitar, I tended to think about chords and chord sequences using their traditional names. So that, we have F, and that's D flat to D, isn't it? We have the standard tritone sub. And so I came up with the tricycle notation, which is an adaptation of standard notation that allows you to uniquely identify pitches in magic temperament, or generally in 5-limit just intonation, as long as you don't move too far. This is what I call evolutionary notation, or I use the term evolutionary, which is used in a lot of suspect contexts, but I've picked it up for this to show that you can think about your chord sequences using standard theory. You don't have to throw away standard theory. You do find a few things that don't work. One thing that doesn't work is a C major chord. Is it here? Because it's that's the comma shifts getting it wrong. But there are a number of standard chord sequences, like that just transfer across correctly. Part of the reason that works is I'm not taking 12-note equal temperaments and adapting it to a guitar. It has nothing to do with 12. I'm taking theory that was devised for mean tone temperaments and applying it to a guitar that is close to a mean tone scale but has these 3 extra commas in it. So yeah, when I said that the standard notation is notating a system of harmonic relations rather than pitches. When you write a major third in notation, if you write a triad, you write which may be the wrong pitch, but anyway, you're saying you want it to sound like a pure chord. You aren't prescribing the exact pitch that a singer or an instrumentalist should produce in most cases. If you are, it can only be relevant to a specific instrument. And so there are different ways of interpreting the pitch, and the notation itself can apply to any system that approximates 5-limit just intonation. That's basically the principle, and that's what I wanted to get across. So I think that'll cover it. So, well, that can work as a conclusion, but it's nice to finish on a thing. If you think about standard notation as writing 12 pitches to the octave, you're not wrong. There are some cases where it does get applied like that, particularly globally. But the more general case in which it's notating harmonies, 5-limit harmonies that may be in just intonation, may be in different temperaments, this is a valid use of the notation, and there are ways of extending it on that basis. So there we go. So thank you for getting to the end of it, and I think I'll call it a day.